Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a continuation video on the chi-square test, and we are on to the topic of independence of attributes. And recalling to the formula given, attributes are nothing but the quality of the characteristics of the behavior, or the property of the content of the raw data given, and the data will be given like A and B, this A and B. And therefore the expected frequencies are calculated using this particular formula here. As I have explained earlier, this will be the row sum, this is column sum divided by the total number, row sum, column sum divided by n, row sum, column sum divided by n, row sum, column sum divided by n. This is how we calculate the expected frequencies of the given raw data. Now, how we will calculate the degrees of freedom? Degrees of freedom is nothing but r minus 1 into s minus 1. R is nothing but the number of rows and s is nothing but the number of columns. So, chi-squared calculated is equal to summation of observed frequency minus expected frequency, the whole square divided by e. Now, we will have a problem on the independence of attributes. The problem is the following table gives the classification of 100 workers according to gender and nature of work. We have to test whether the nature of work is independent of the gender of the workers. So what we are given with is, you are given with the 100 workers and their attributes. What are the attributes? Their gender and their nature. These are the two attributes given. So we are going to test for the independence of these two attributes, whether they are stable or unstable. So, according to the gender and nature of the given raw data, we are going to analyze whether they are stable or unstable. What we are asked to check with? We are asked to check whether the nature of the work is independent of the gender of the worker or not. This is what we are asked to check. So, what is the data given here? Data is for male, stable data is 40, unstable data is 20, and the total is 60. And for female, stable data is 10, unstable data is 30, and for total data is 40. This is what we are given with. How to perform this independence of attributes problem? To start with, you are given with the data. R is equal to number of rows is equal to 2 and number of columns is also equal to 2. Therefore, the degrees of freedom is 1. This is r minus 1 into s minus 1. Therefore, it will be 1. How we will calculate the expected frequency? Expected frequency is row sum into column sum divided by the total number n. This is row sum. This is column sum divided by n. How we have taken is, we will just take up these two things and these two things and together. Row sum into column sum divided by the total number n. This is what we have done here. 50 into 60 divided by 100, just 30 for the first term, 30 for the first term, 30 for the second term, 20 for the first term, and 20 for the second term. This is what we have got as expected frequency. So the total, we have to also note that the total should be always same here, which is 100. 100 is the total frequency. For on either sides, we will be having the same value as 100. Moving on to the problem. The first step is to set up the null hypothesis. What is our null hypothesis? H naught. It is the nature of work does not depend on gender of the workers. What we will set usually means, null hypothesis means there is no significant difference between the given two attributes as our null hypothesis generalized term. But here, as per the question given, we will be noting it as the nature of work does not depend on the gender. The nature of work does not depend on the gender is our null hypothesis. Then now, as usually, we will be calculating the test statistic. What is our test statistic? chi-squared calculated is summation of O minus E the whole square divided by E. With the help of the table, we have found the value of chi-squared calculated is equal to 16.66. And also the thing to be noted here is the expected frequencies are from the previous table as per the formula, which is row sum into column sum divided by the total number n. As per the data given, as per the formula also, we have calculated expected frequencies for each and every the observed frequency. So, the chi-square calculated value is 16.66 and chi-square tabulated value for 1 degree of freedom and 5% level of significance as per the standardized table, we have got the value as 3.84. Now, what we will be doing in the next step is we have to just compare the calculated value and the tabulated value. What is our calculated value? It is 16.66 and what is our tabulated value? It is 3.84. So, chi-square calculated value is found to be greater than the tabulated value. So what we will do, we will obviously reject the null hypothesis. What is our null hypothesis? As discussed earlier, the nature of the work does not depend on the gender of the workers. But here we have rejected this null hypothesis, therefore we will be accepting the alternative hypothesis. What might be our alternative hypothesis? The nature of the work does depends on the gender of the workers. So this is our conclusion as per the chi-square test performed here. So as per the formula given, we have transformed the raw data into our known frequencies and the expected frequencies, and as per the observed frequencies, what we have inferred? We have inferred that the nature of the work depends on the gender of the workers. So this is what we have concluded using chi-square test. So this is how we perform a chi-square test in the with the procedure given. So we will continue a case study on the next video as well. Thank you.